Here's an example of an optimization problem. This has to do with a tank that catches runoff water. So the problem states that an 1125 cubic foot open-topped rectangular tank with the square base x feet on a side and y feet deep is to be built with its top flush with the ground to catch runoff water. The costs associated with the tank involve not only the material from which the tank is made, but also an excavation charge proportional to the product x times y. We're asked that if the total cost for constructing the tank, of course, is given by C is equal to 5 times the quantity x squared plus 4xy plus 10xy, what values of x and y will minimize the cost? So this is a classic optimization problem. So this problem, we have a tank. It has certain dimensions. We're told what the volume of the tank is, specifically 1125 cubic feet. And we're supposed to find the dimensions that will minimize the cost of actually constructing the tank. So the first thing we need to do is, after we've read the problem and got some understandings, we need to draw a picture. Remember that we were told that our tank had a square base. So I've labeled the base of this tank as x and x. And then it's got a deepness or height of y. And the total volume of this open-top tank is supposed to be 1125 cubic feet. So we know that x squared times y is equal to 1125 cubic feet because that would be the equation for the volume of the tank with those dimensions. Now this x squared y equals 1125 is going to be our constraint equation. This is going to be the equation that's going to let us know that no matter what we do, we have to maintain dimensions so that we have the same cubic feet for the volume. If I use that constraint equation, I can then solve for one of the variables, and I'm solving for y here. So y is equal to 1125 divided by x squared. Now, we need an equation now to optimize, and so we know that we're told that we must optimize the cost, which is 5 times the quantity x squared plus 4xy plus 10xy, and we're going to use the information from the constraint equation, which tells us that y is equal to 1125 over x squared. So our next move will be to substitute 1125x squared in everywhere we see a y. When we do that carefully, we get 5 times the quantity x squared plus x, 4x times 1125 over x squared, which is now what y used to be, plus 10 times x times 1125 over x squared, again substituting for y. If we multiply through, we get that 5x squared plus 22,500 over x plus 11,250 over x is equal to the cost. We then simplify and we get that 5x squared plus 33,750 over x is the cost after we substituted in our constraint, which was y was equal to 1125 over x squared actually. So our cost is now 5x squared plus 33,750 over x. We need to take the derivative of that to get our critical value. And so if we carefully take the derivative, we know that the derivative of 5x squared is 10x. And then the derivative of 1 over x is minus 1 over x squared. And that 1 over x in the cost function is multiplied by 33,750. So we get that our derivative is 10x minus 33,750 over x squared. We then get a common denominator because this is the only way we're going to be able to determine our critical values. And so the common denominator is x squared, and we get that c prime is equal to 10x cubed minus 33,750 divided by x squared. We want to remember also that we need to come up with some reasonable limits for any function we're trying to optimize. And so our cost function is 5x squared plus 33,750 over x. From the mathematics, we see that x certainly has to be greater than 0, otherwise that function is undefined. And x could go to infinity if we let our costs go that way. So the possibilities are anywhere between 0 to infinity, and that's an open interval. So we know, since we had an x in the denominator, that c prime is going to be undefined when x is equal to 0. And we recall that that's not in the domain, so we won't have to worry about x equals 0 as a critical value. And then also c prime of x is equal to 0 when that numerator, which was x cubed minus 3,375, and we got that when we divided everything by 10. So we need to set that equal to 0. If we do, we see that x is equal to the cube root of 3,375, or 15 feet. So next we need to check the limit of our cost function as we approach 0 from the right and infinity. And when we do that, and you can verify that when you take the limit as x goes to 0, you get a 0 in the second term in the denominator, which is 33,750 over 0, or something that goes to 0, which is positive infinity. And of course, that first term, 5x squared, goes to 0, so you get positive infinity for that one. And you get positive infinity if you take the limit as x goes to infinity for that cost function. If you plug in the critical value 15, then you get $1,350. So really the only question that is left is, does x equal 15 feet give a maximum or a minimum? This is important because we were looking for a minimum cost. So we can use our second derivative test to determine this. So we have our first derivative, which was 10x minus 33,750 over x squared. We'll carefully take our second derivative, and you can verify that that will give me 10 plus 67,500 over x cubed. And to get that derivative, just take that second term in the first derivative and write that one as minus 33,750 times x to the minus 2. Use your power rule and you get what I've got. So I've got the second derivative, and so using the second derivative test, I need to plug my critical value into that second derivative. When I do, it is clear that c double prime of 15 is greater than 0 because 10 is positive and 67,500 over x cubed is positive as long as the x value you plug in is positive. So when you add two positive numbers, that's positive. So if our second derivative is greater than 0, recall that that indicates that we have a minimum at that value. So this tells us that we do have a minimum at x equals 15 feet. So the only thing left to do now is to actually go and find that other dimension x. I'm sorry, I actually have x, so we want to find the other dimension y. And so plugging into our constraint equation, we get that y is equal to 1125 over x squared, or 1125 over 225. And so y is equal to 5 feet, and x is equal to 15 feet.